Okay, today is March 14th. I'm not sure if that rings a bell with anybody, but March 14th, 2011 is officially Pi Day. Not the kind of pie you eat, but the number that represents a circle's circumference divided by its diameter. That's equal to pi, the Roman or the Greek letter pi. Okay, so how do you calculate pi, or how do you approximate pi? What's the value of pi? How do we come up with that? Well, my son, he keeps insisting that the most accurate way to calculate pi is to take a string, take a circle, and wrap a string around a circle and carefully measure that distance, and then take that same string and string it across the circle and carefully measure that, and you're going to have a very accurate value for pi. Well, that will give you a good approximation, but there's another method that's been used for a couple thousand years, and it was actually the most popular method that was used up until about Newton's time. So up until Newton, the best way that we knew to calculate or approximate pi was to take a polygon. Polygon is everybody knows what a polygon is, right? A polygon is just a shape that has a number of sides. So you could have 1, 2, 3, 4, 5 sides, or you could have a 6-sided polygon. 1, 2, 3, 4, 5. You could have a 6-sided polygon, or you can have a 10-sided polygon, or you can have a 1,000-sided polygon. So a polygon just means many sides. So how do you use a polygon to approximate pi? Well, you draw your polygon on the outside of the circle, right? And then you draw, let's see, I'm not doing a very good job here of drawing this, but okay. And then you draw your polygon. So this would be 1, 2, 3, 4, 5, 6 sides, 6-sided polygon. And then you draw the polygon with 6 sides on the inside of the circle. And notice how I'm using the points from the outside polygon that touch the circle. We'll do this in a different color for the polygon that goes on the inside. So these are the points that touch the circle here, and those are going to be the ones that I use to make my polygon. So the polygon on the outside has 6 sides, and the polygon on the inside also has 6 sides. So now if we have a way to calculate the length of these polygons, the perimeter of these polygons, we know that the polygon on the inside, so the length, we'll call that length 1. That's the length of the polygon on the inside. Length 1 is going to be less than the circumference, and that is going to be less than the polygon on the outside of the circle. We'll call that length 2. Okay, and then to get to turn this into pi, we just divide everything by the diameter, and now we'll have, let's call this well, let's see, we'll just call it, I don't want to call it circumference because it's not a circumference, but let's just call it A is less than pi is less than, we'll call this one B. Okay, so now you can see as we add more and more sides to our polygon, we're going to have a closer and closer approximation to pi, which is circumference over diameter. So real quick, let's just try this with the simplest polygon that I know how to do this with, and that would be a square. So we're going to take our circle That's a circle. And we're going to take a square and put the square on the outside of the circle. And by the way, this is going to be a really terrible approximation of pi. In fact, my son's approximation using the string is going to definitely be much better than the approximation of pi using a square as your polygon. But I just want to illustrate, this is just to illustrate the method. Okay, 4 sides is going to be a very poor approximation, but if you were to use 1,000 sides or even 100 sides, you're going to have a pretty close approximation, and we know that pi is actually going to be close to 3.14159 dot 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 dot. It just goes on and on and on indefinitely. Okay, so let's use, we need to decide the length of our radius of our circle. Oh, and by the way, I meant to mention this, but pi, the ratio of the circumference to the diameter of a circle, pi, is going to be the same value for a small circle as it is for a medium-sized circle, as it is for even a larger circle. So the ratio stays the same. That's the neat thing about pi, is it doesn't matter how big or small your circle is. Pi for any given circle is always going to be the same value. Okay, so let's just say for this particular circle that we're using, we're going to use it. You're going to use a unit circle. Okay, unit circle. And the unit circle is defined to have a radius equal to 1. Okay, so this radius here is equal to 1. That's going to help us calculate the length of these squares. In fact, you can see the outside square is extremely simple to calculate. If the radius of the circle is 1, then you know that this length here is also equal to 1, and this length here is 1, and all these lengths from the middle of the side out are equal to 1. So the total distance around this first square is going to be equal to, add them up, and that's equal to 8. So the outside polygon, the length is going to be equal to 8. And that's going to be less than our, let's see, diameter. Oh wait, no, sorry. Circumference. Less than our circumference. That's a C. Oh my gosh, it's a terrible C. All right, and that's going to be less than, now we have to figure out the length of this inside square. Okay, now that's going to be pretty easy to figure out as well, because we already know the Pythagorean theorem. I posted that one a couple weeks ago. And so if you've got a right angle here, and you've got sides that are both equal to 1, then this side is going to be easy to, we'll put a question mark there for now, but we'll figure that out. Remember, Pythagorean theorem says a squared plus b squared is equal to c squared. In this case, our triangle looks like this, sort of. And let's see, this is equal to 1, that would be a, and b is also equal to 1, so what is c? Well, if we've got a is equal to 1, that's 1 squared plus 1 squared equals c squared. So 1 squared is 1, so we've got 1 plus 1 equals c squared. 2 is equal to c squared. Now, to get the square, to figure out a square, we have to take the square root of both sides, and so c is equal to the square root of 2. Now, I would love to show you a way to calculate square roots without using a calculator, but I don't have time right now, so we're just going to use a calculator. Let's see, there's our calculator. And so c is equal to square root of 2. What is the square root of 2? Let's see. It's equal to 1.41421. It's close enough. 1.41421. All right. So let's see. You know what? Let's keep it as square root of 2 for now. Sorry, it's just easier to add the square root of 2 4 times. So this is the square root of 2, this is the square root of 2, this is the square root of 2, and that's the square root of 2. So the area around this smaller square is 4 times the square root of 2. Now let's bring our calculator back and figure out what that is. So we want 4 times the square root of 2. So multiply this times 4. That can't be. Oh, yes, that's right. That is right. 5.656. Okay, because we aren't calculating pi, we're calculating the circumference right now. If we want to calculate pi, sorry, this has gotten confusing. Remember, pi is equal to circumference divided by diameter. Divided by diameter, divided by diameter. Now our diameter here happens to be, well, our radius is 1, so our diameter is 1 plus 1 is equal to 2. So our diameter is 2. So our approximation of pi is going to be, this is equal to 2, this is pi, and that's 2. So we take this, go back to our calculator, divide this by 2. That's much better. Okay, so pi is somewhere between 2.82847. 828. We'll just call it 828. It's less than, pi is less than 8 divided by 2 is 4. So I told you this is a very rough approximation, just trying to illustrate the method that people have used to calculate pi for thousands, a couple thousand years anyway. And you start adding more sides and you're going to get a much closer approximation to pi, which we know is going to be about 3.14159. So that's it. I might do another video that uses more polygon or more sides to the polygon, but that should do it for now. Happy Pi Day.